This video is going to continue to look at some examples working with ellipses. And here we have again a reference for our standard equation of the ellipse. X minus h squared over a squared plus y minus k squared over b squared equals 1. If we have a horizontal, the a value is the larger underneath the x squared. And for the vertical, our a squared is underneath the y minus k squared. And of course, the c value is calculated by c squared equals a squared minus b squared. So let's look at our first example. We have x squared over 64 plus y squared over 28 is equal to 1. So first of all, we'll notice that here we have the 64 is the larger number, is underneath the x squared, so that means that it's going to be horizontal. And we can tell that there's nothing subtracted or added to the x squared or the y at the top. So therefore we know the center, which is our h and k, is going to be at the origin, 0, 0. And now we need to actually calculate our a value, our b value, and our c value. So here we have a squared is going to be equal to 64. So therefore a is going to be equal to the square root of 64, which is 8. And b squared is going to be equal to the 28. So therefore b is going to be equal to the square root of 28. And we could break that down. We could think of that as 4 times 7 is 28. So if we think of that as 4 times 7, then the square root of 4 would be 2, and you're left with the square root of 7. Or if we put that into the calculator, that's going to be approximately 5.3. So we have our a and b value, so then all we have left to do is calculate the c value. And c is going to be c squared is equal to a squared, which is 64, minus the b squared is 28. So then if we put that in, subtract and take the square root, your c value then is going to be equal to 6. So now we want to look at, again, looking at a rough sketch of the graph. We know that the center is once again at the origin, 0, 0. And if we go from the center, and keep in mind this is horizontal, from the center to a vertex is going to be our a value. So that means we're going to go out 8 units, or 8 places, 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So all the way here to positive 8 and negative 8. And then of course our b value that we have here, we said that's a little bit more than 5, so we could go 1, 2, 3, 4, 5. So roughly say here, and if we go down 1, 2, 3, 4, 5, that would be here and here. So then we have our ellipse, something like this. And now we can go back and actually label our vertices. So here we have one, here's the other one. So the vertices, the actual coordinates would be, one is negative 8, 0, the other one's positive 8 and 0. So we could write that as positive or negative 8 for the x, and of the y coordinate would be 0. And then of course if we're looking at calculating the foci, we know that's going to be from the center out to the foci is going to be our c value, which we just calculated was equal to 6. So 1, 2, 3, 4, 5, 6 here at negative 6, and then 1, 2, 3, 4, 5, 6 at a positive 6. And once again, that would be, we would have your x value would be positive or negative 6, and of course the y coordinate would be 0. And then next we have the eccentricity. And remember that is E is equal to C over A, so the C value is 6, Our a value is 8, so we have 6 over 8, which reduces to 3/4, which would be the same thing as 0.75. And again, this is closer to 1, so we can see that it does have more of an elongated shape. Again, if this 0.75, if this is close, the closer this number is to 0, the more it's going to be circular. So there we have the graph of the x squared over 64 plus y squared over 28 equals 1. Okay, for the next example, we have the equation x minus 4 squared divided by 16 plus y plus 1 squared divided by 25 equals to 1. Now this is already in standard form. It's equal to 1. We have our x minus h squared over 16 and a y minus k squared over, in this case, 25. So now we look at the two values. We have a 16 and a 25. Over here, the 25 is the bigger value, so we know that's going to be our a squared. So if that's the case, then we have a squared is equal to 25 and b squared is equal to the 16. So that means a is equal to 25, b is equal to 4, and if we're looking at our c squared, remember that's going to be a squared, so that's 25 minus b squared, which is 16. So 25 minus 16 is equal to 9, and the square root of 9 would be 3. And then, of course, if we're looking at the center of the ellipse, that means we're looking at here our h and our k value. Notice now this time we're subtracting something away. The previous video and the one in the earlier video, notice we just had an x squared on top and a y squared. There's nothing being subtracted, so the center was at the origin. But now we have a minus 4 and a plus k, and we need to keep in mind the formula says it's x minus h squared and y minus k squared. So just like when we were looking at the formula for the parabola, the minus sign's already here, so that means our h value is going to be a positive 4, and our k value is going to be a negative 1. So the center is at 4, negative 1, and again we want to kind of look at where that's going to be located. So if we go over 1, 2, 3, 4, and down negative 1, here we have the center, whoops, this is the center of our ellipse. All right, so then we can from here calculate the vertices. And remember, the vertices are located a units from the center. And now, whoops, I forgot to mention here, our a value is underneath, the a squared is underneath the y squared, so that means this would be, or would have, a vertical axis. So that means our ellipse is going to go this direction. So here we're going to have our vertices are going to be here at the bottom and the top of the ellipse. So in this case, our a value is 5, so that means we're going to need to go up 5 units. Now when we do that, notice we're already at negative 1, so that means we need to take our y value over here that's at negative 1, and we need to add our a value. So if we have a negative 1 plus 5, or we could simply count up 1, 2, 3, 4, 5, and we're going to end up with our vertex at 4. And then we could take a negative 1 and subtract 5, or we could simply just count down 1, 2, 3, 4, 5, and we would be at a negative 6. So there we have our two vertices. That's going to be at positive 4, 4. Okay, so the one here at the top is at 4, 4. The one here at the bottom would be at 4, negative 6. All right, so then we could also look at our b value, which is 4, which that means we're going to go 4 units. In this case, for the minor axis, we go 4 to the left, so 1, 2, 3, 4 if we count. Obviously, that's going to put us here at the origin. And we could go 1, 2, 3, 4 to the right. Whoops, and I forgot to go down 1. Let's see here, this is not at the origin. We're going from the center here, so we need to count over 4. So that would be here. And then if we were to count over 4 units, then that would put us here at 8. Now remember, we're down at -1. So then we would have our ellipse that would look something like this. Try to draw that a little bit better here. Not quite drawn to scale, but again, just as long as we have a reference for this. And then we can look at finding our foci. And again, they're going to be on the major axis, which here once again is vertical. And the distance from the center to the foci is going to be the c value, which is 3. So in that case, that means we're going to go up 3 units. So 1, 2, 3, which would put us here. And if we're going up 3 units, keep in mind if this is our center here, this is at 4, -1. So if we're going up 3 units, we're going to add 3 to the -1, which would put us at 2. And we're going to go down 3, so -1 minus 3 would put us at a -4. So there we have our foci, which would be located at +4, +2, and then +4, -4. And then, of course, the last thing we want to look at is the eccentricity. And again, that is our c value over a. So our c value in this case is 3 over a value of 5, which is 3/5. So that just, again, tells us a little bit about the either how circular or how more elongated the ellipse is. Okay, so hopefully now you're starting to get the hang of this. This is one that had a center at 4, -1, whereas the other two had a center at the origin. So you can see the difference of nothing being subtracted, or in this case where we're subtracting away the x minus 4 and we have the y plus 1. That gives us the center of h and k.